Hello everyone, welcome to our class. Today we will start to talk about the process. What's a process? Process is a one abstraction of your operating systems. Your operating systems package each of your program inside a process and run it like synchronously. So imagine that you have a couple different programs. You have your Chrome, you have your maybe your game stuff, and you have your other like software like you have Excel or PowerPoint like when you do the homework. You have a couple different software like opened when you watch these videos. How your operating systems manage this? They are managed by the process. So each of these programs is packaged into a process and managed by your operating systems. So what the process means? Actually, you can imagine that the process is like a state. What's the state? The memory state and machine state. So when you execute particular code, and you can see the code is also in the memory. When you see a particular line of code, the program it's like exit in a particular state. Which line is executed? Which memory format is needed? Which registers format is needed? So there's a whole couple you can imagine at this moment, like which line of the code, which memory look like, what's the register look like, everything together is kind of a state. And process is kind of the state. The process contain the memory information, contain the registers information, contain all the informations you need to run the program, to continue to run the program after this moment. Okay, so in this case, because we have so many process inside operating system, even if assume you just use one core computer, you only have one CPU and you need so many process. How is actually do? It's actually do is I run this process first, then I stop it. I run this second, and it's finished. I get rid of it. Then I come back to continue to run this one. So it's kind of the we call it a context switch. So we run this one, then we run this one, we run a third one, third one finish, we maybe go back to the second one. We just kind of run every process like synchronously, but they are not synchronously. It's just based on some schedule. Okay, so operating system has a schedule to manage this process running. It does not finish one process then go to the next one. If your operating system do this, then you cannot work like synchronously, right? So you actually that's a context switch managed by your operating systems. So because of this context switch, let we have a concept called exception. So what's an exception? Exception is not always bad. Actually, exception means when you run this program and you got stopped because of an exception. So if you run particular program, this program just stop, don't continue to run. The other program might be just like start running or not. So this is we call exception. So exception means you got some interrupt. So actually, what's the exception? The exception that's a can happen in different level. The exception can happen in hardware level, operating systems, or user level. So what's the example for hardware level? For example, you are waiting for a network. Your software are waiting for some data from the network from other computer in your server, in the server. In this case, your program stop because the program want to wait for the data, right? It stop. This is the exception because when it stops, it does not continue to run. And maybe we can run other program or not. But you can see it's the control flow is getting stopped because of something happened. This is not terrible. This is usual, right? Your program want to wait for some particular data to continue to run. So this is usual. So in this kind of case, it's a hardware labels like a exception is exception control flow. Okay. Another part is what we say is a context switch. So when we do context switch, for example, your operating system want to run another program. Maybe another program is very important. For example, your mom's code, your father's code. They are very important code. You make it really high priority. So your operating systems will always deal with this kind of process first. In this case, it will stop your maybe your gaming stuff, maybe stop your Excel, this kind of like a document stuff. It just continue to focus on this particular one more. So that's the context switch, right? So actually, system do the context switch based on the table, not just so naive like this party is higher, so I just run it until it's finished. No, it's not like this. You can learn more about this context switch in other courses like operating systems. But here you got the idea. Your process manage so many different processes. So it might interrupt particular one, then try to run another one. So this is also exception, right? Another part we call user. What's a user exception? When you try to work on particular process and you want to go to another one, what happened? You can kind of like stop, suspend it, right? Suspend. So you have a power to suspend your process. You don't want to kill the process. You don't want to stop. You don't want to finish the program. You still want to use it, but you want it to be suspend. And very famous example is use Control Z in your Linux system. Use a Control Z, put your software, you put your process, go to a background. Then you can do any other stuff. So by user's signal, user can type something to make a signal. The signal can make your program kind of suspend or stop. This is also another exception. So actually exception is not bad, it's usual. But exception here means your program got stopped, get suspended because of some reason. Maybe from the network, you try to load get data from network, you want to wait for it, or your operating system try to do a context switch, or user want to stop it, suspend it for a while. Okay, so if you understand the exception, this is the idea how to handle exception. Actually, inside the operating systems, there's an exception table. There's a whole bunch of different exception already predefined, predefined layer. Then when your program try to run something and it gets the exception, for example, event K, some event. So exception is like an event. So it's get some event exception. Your operating system will take a look up the table, try to match the code for this table. For example, we need to find the K1. Okay, so your operation system will check the code for exception K handler, exception handler for the case K. Then based on the handler's decision, for example, the handler is if this is the exception, we want to like it's a very important serious problems cause this exception, and inside the code for this exception handler is will define, okay, this is series one, we should stop the program. So based on the table, based on the handler, we will make the process. There's a couple way to like make a process finish. You know? So if it's series, you just terminate it. You can terminate the process. So we just complete, we just kill this process. We don't want to continue to run because there's a serious problem. And or it can be just something like okay, suspend. We want it to stop, to wait until some other signal. For example, until student people like a user to wake it up. Or some exception, it does not actually it will be ignored. So we found the exception, but it's fine. We just continue to run this process because this is exception is so minor. So by default, on the default handler, we say, oh, it's fine. We just continue to run. So there's a couple behavior might happen, a couple action, couple solution might happen when the exception happen. Okay. So this is the idea of exception. Actually, there's a couple different kind of exceptions. We can talk about this a little bit. This exception, not all the exception is bad, but some exception might be very bad. For example, this one. This exception we call abode. Abode means what? Your program count a very serious problem. For example, divide by zero. This divide by zero problem is very bad. So this exception, you should like take it really serious. So in this case, the table will define it, say, okay, this is the exception we cannot handle. We cannot like allow this program continue to run. So we define it as a non-recoverable. So the exception happen is not recoverable. It should stop. It should the process should be killed. The process should finish. Okay. There's some exception, serious exception like this. But in other way, there's other exception is very, very simple, very usual, very common. We don't do anything. For example, like this. Some signal from your IO device to make a exception. For example, you use your keyboard Ctrl Z to like suspend it, or you try to do like a some other like a signal. You use user program. You use other program try to communicate to this like the process. And in this case, they are just like some usual part. Like they are common. They don't create any problem. So this kind of exception is recoverable. It's totally recoverable. Another exception might be a system call. So when we use system call a lot, because system call is really like a kind of fundamentals in your kernel, in your operating systems. So we use this system call a lot. When you do this system call, uh, it try to do some complicated as what we cover in other videos. You can see it's actually like a change your operating system change the process to a kernel mode, and you inside kernel mode is do something and so on. So actually the system code is also exception, called some exception we call trap. This trap is not too bad. It's actually it's fine. It's very similar to interrupt. It's very fine. It's the difference just like okay, this is from the system code is just from some like your a usual behavior from your operating systems. So it's okay. It's recoverable. This is recoverable. And the last part, the fault. What's a fault? One very like a popular famous one is page fault. Page fault means what? You want to access a memory, particular memory address, but the memory address is some like private and you are not allowed to do it. So your operating system say, okay, this memory address you are not allowed to do. For example, you try to access the memory address is not defined in your algorithm, or they are like a kind of private. You got segmental fault, right? You got segmental fault because you access some memory you are not allowed to do. Very similar to it here. When you do a patch 4, you try to access some memory patch. It's not for you. It's might be from it might be for like other like like status of a process. It might it's need to be managed by the operating system, not for the user. So in this kind of stuff, the page 4 can also call exception. And based on how you deal with the page 4, this might be recoverable, might not. It's potentially recoverable if you have some way to manage to handle it, but it's not always could be manageable. So just as I said, a segmental 4, you have a segmental 4, your program just gets stopped because uh, if you don't do any like other special treatment, it's just getting stopped. So this is another kind of exception. So actually, there's a couple of different exception. Some exception, not all exception is bad, right? Because like an interrupt or trap, this just very common, and you will see this exception a lot. But for other two, it might cause problem. So you need to pay more attention on this kind of like exception. Okay, so in summary, what's the process? What's the process and what's the exception in process do? The process is an independent logic control flow. Why is independent? Because we use virtual memory to save the code, to save the states, to save the memory. So they have independent logic control flow, and they have a private address space in virtual memory to support the process. And the exception happened when the control flow, when you try to continue to run the control flow, but it gets stopped. The exception might, the reason to cause the exception might be very like a, might be very usual one. Your operating system want to run another process. It can be a terrible one, like okay, your code caused some problem, and your CPU cannot compute it anymore. So you need to like kind of like check the exceptions in your process. What kind of exception in your process if you really care how the process work in the operating systems. Okay, so the process in your Linux, in the Linux systems is managed by in a like kind of a tree. So actually the process itself is kind of a hierarchy. So it's not just like what we have before. It's not like this. Just operating systems control one by one, they are kind of parallel. Actually, this is right. Operating systems control each like a single process, but the process have some relationship. It does not shows here. What's the relationship between process? Process can create another process. We will talk about this in other videos. So the process can be created by another process, which means you can have a family of process. The process can have its parent process. So this is a parent, this is a child. Okay, so because a process can create another process, so you can see this like a family hierarchy tree. And on the Linux, we have the first process called initial. This one is the parents of all the process. And from here, you can generate this like a process tree. How to see these informations in your program? This is an example, very simple example. Actually, how to see it? We can use a get PID to get the process ID of current process. We can use get PPID to get the process parent process. So what's the parent process of a current process? So this one, get parent. This one, get itself. So by using this get PID, get PPID system code, you can get the information about this like process and other process. You can kind of get the basic information for this. So try this code in your machine, try to type it, try to like run it to see what happens. You will find it's really interesting to see this like a whole bunch of stuff. And you will and remember if you in the linear systems there's a PS. When you type PS, you can also see what the process is running in your code or suspend in your machine. Then you can kind of compare the status inside when you use PS, you can get all the information, right? Compare the informations to the information you try to print here, and you will find it's really interesting in your systems. Okay. Okay. So you now you have an understanding. You have an idea about like what's a process, what's the exception, and what's the process like hierarchy tree in your Linux systems. Then we can talk about the status of each process. Actually, there's a three statuses of each process. One is called running. The running means you are running this process. So it's just a regular one. Your CPU is taking care of this process. Your operating system send this process. Now it's your time, and it's keep running. Stop. The process is stop can be for from an exception. If you have an exception, the process might be stopped, or you have a context switch. For example, operating systems want to stop it because it's run another process. It's just getting stopped, or your user, the user just want to stop it until at some moment you like wake it up, like then continue. Another part is the terminated. Terminated means the process finish. The process finish can be it's just done what it want to do. It's just finish all the code or the instructions, then finish. Or it can be killed by other process or by user or by operating systems because of some like a serious exception. So this is in general, this is the status of the process. So you can go from start to running, you can go running to terminated, you can start from start to go to a terminated. There's a couple different like a transition here can happen in the process, okay? So let's give you an example how to terminate the process. Actually, this example is so simple. You already know it. We use exit. When we do exit means we finish this process. Exit does not equal to, they are not equal, it's not equal to return. Return means we return to the caller function. So we finish this function, we go back to the caller. Exit just terminated the process, the program. No matter where no matter where you put this exit, which function you put this exit, it just terminated the whole program immediately. It does not go back to the caller functions or other functions. Okay, so the exit is the one you can terminate your program, and you can see the description is here. The description is here. The exit cause normal process termination. Okay, so you terminate the process by using exit. Of course, there's some minor information here. What's the status of Z0377? 0377 in octal, this is an octal number. This is just an octal number. This is not the decimal number. It's a non-binary number. So, but actually, if we change the octal number into the decimal, what you can do, what you can see is it will become 0xFF. So what this means? 1 byte, right? So this is a byte. This is a byte. You have 2 bytes of F, which means you have 0 x 1 1 1 1 1 1 1 1 1 1 1 1 1 1. You have something like that. You just make all 1 here. Why? Why you need this? Okay, so it's just like very minor information because in the older machine, it does not 32-bit machine, they use 16-bit. So if they use 16-bit, we only take care of the last 16-bit. We don't care like other upper level like upper bit. So this is just some match to some old-fashioned machine. So it's not like a so it's not too weird, but sometimes in the document you will see some weird magic number in the document, and don't scare because sometimes it just sounds like a match to other previous systems. The idea is the same. The status is what we actually want to tell your user or your like operating systems. What's the number? What's the status when this program terminated? So today, thanks for watching these videos. Today we talk about a very general, basic like a concept of a process. We talk about the process and exception. So what the exception means, and we talk about what kind of exception you can have. And we also talk about when you have an exception, what kind of stuff might happen, what happens when you have an exception. And we also talk about the status of your process. There's a three different status of your process and how to credit the process and how to check the process ID and how to check the parent process ID. We talk about the process hierarchy, the tree in your Linux systems. So I hope you got these ideas today and see you next time. The process and exception is awesome.